Should we get started then? Okay, good. I was waiting for something, I don't know. But first, I need to take a picture, so um, to all of you, it's going to be, just do something like, I don't know, raise your hands or something. There we go, go. There we go, good. So, yeah, finally, we are ready to start here. Okay, good. First question, how many of you are Android developers here? Is there any iOS developer? Good to know. So the reason behind this question is because I'm going to be talking about multi-threading today. And this doesn't apply only to Android. So that's the reason here. The first thing I want to mention, first, thanks to the organization for bringing me here. Unfortunately, today I will have to run to the airport after the talk. I will have still 15 minutes or something to just talk to you guys. But yeah, I have another commitment, but I managed to make it here, and I'm really having a good time in your country. So, in order to get started, so I'm Fernando Cejas. I'm a developer. I'm here only to share all the disasters I made as a developer. I'm not a good developer, that's what I say. I learn out of mistakes. I have a blog. I'm social, try to be social within Twitter and all the social networks, so feel free to ping me there with questions. I would be more than happy to help out. I'm from Argentina. We still don't have representation in the Street Fighter map. We are fighting against that. So, and this is my tiny family. So mom, sister, and me. And this is where everything started, when I started preparing this talk. So I was sitting with my mom, sister grabbing a beer. And then at some point, I just asked, Mom, what is multi-threading? And she said, okay, my son, you're still not prepared to know about multi-threading. Because, you know, like multi-threading is a taboo topic most of the time, right? So she basically said, may the force of multi-threading with you. And so that's why I started investigating a little bit and said, okay, what happens always when we talk about multi-threading? There's a lot of quotes out there, and multi-threading is always hard. Multi-threading, you know, our programs are not ready to run in multi-threaded environments. And many things like this. Yeah, the wall is there. Now with all these cores that we have at this hardware level, then it's super complicated to, I don't know, develop software which can run in all these cores at the same time. And that's why I decided, okay, let's bring up all the software engineering concepts here, and let's try to understand what's going on with multi-threading and why we need multi-threading. But the first thing, I always like to relate something new that I'm learning or investigating with the reality. So let's say we as human beings, we are not multitasking. It is hard to believe. Sometimes we think we are. And there is in part, that's in part is true. Like we can do some specific tasks at the same time. For example, we could, I don't know, drive while having a conversation. Because that's a kind of an autopilot thing. But when we start texting, that involves more power, more brain power, and that's when things get complicated. Actually, there's the front part of the brain is what controls this multitasking, which is not true in the end. It's like, it's basically we are switching contexts all the time. Super fast, of course. You know, some people do it faster, other people are slower, I'm slower. But in the end, there's no multitasking. It's proved, and these autopilot things is because there's other part of the brain involved here. But anyway, we are not, but computers are. Computers can run things in parallel, concurrently. And that brings me to two concepts. What is parallelism and concurrency? Do you think that it's the same thing? No? Okay, good to know that, because many people actually are confused because of these two things. What is, running things in parallel? What is running things concurrently? So that's the first difference. So we need to have a clear concept of what parallel is and what concurrent is. So parallel means that we are doing things in parallel at the same time, right? And concurrent or concurrency is dealing with a lot of different things. So let me put it in another way. So if we were here writing letters, all of us, dear mom, what is multithreading? And we are all doing the same thing, that means we are running all this in parallel. But that's not concurrent, because it's only one thing, right? At a mobile development level, we are dealing with many things in parallel. So we need to keep an eye on, users, clicks, all kind of events happening there in our mobile phones. By the way, these talks can apply to any software project in the end. I'm going to be specifically talking about mobile because I consider it important and it's part of what I do in my day-to-day life. But in the end, all the concepts applied here could be applied to any software engineering project. So, with that being said, this talk is going to be about threading. The whys, I will tell you later. I'm not going to talk about Android specifics. Actually, Jonathan, in the previous talk, did a great job, explaining, what's going on under the hoods with all this background thing. But I think there's more than that. You can go deeper, and learning the fundamentals is very important, right? Because in the end, everything is going to end up in threads and in all this. All these abstraction layers that we are seeing on Android or on any other frameworks are going to end up, with threads. So let's review a couple of concepts before continuing. The process, we know what a process is. Let's say it's an instance of an application for now. A thread, it's a bunch of these instructions, like let's say a task. Let's relate it this simple way, like that. Mutability, important concept in multi-threaded environments. We don't want to constantly change state, mutate our objects or functions or whatever. Should be immutable, and we're going to get back to it later. So there's a bunch of situations related with multi-threading. So there's a deadlock when two tasks are blocked with each other. Keep it simple. Two threads are blocked, they cannot continue their execution. A race condition, their two threads are racing to get access to any shared resource here. Starvation, which is kind of in the middle, so that means that two threads are fighting for a resource, and when that shared resource is caught by one thread, this thread retains a lot of time, this shared resource, and the other thread cannot, make progress. So it's basically slowing down other threads from accessing a shared resource, for example. Okay, good. Just a quick thing. It was already mentioned in the previous talk, but how Android works. Just to keep in mind that Android works pretty much like Linux. It's a mini version, let's say. Let's keep it simple again. When we start an application, a new Linux process is cloned, and it starts with only one thread, the UI thread. I guess iOS works the same way. So there is one UI thread, and we need to keep an eye on that and not perform like long running tasks in the UI thread, because otherwise we are going to have an impact on user responsiveness. We don't want users to uninstall our apps. So, oops, glitch in the matrix, some overlapping there. Anyway, why multi-threading? What I said, learning the fundamentals is important because that's going to give you more, I don't know, problem-solving skill sets, because we know where to find what's going on, what's happening under the hoods. But the real reason why we are doing things in a multi-threading environment has to do with responsiveness, because we are using, we are being more performant, let's say, and that's going to be awesome for our users, right? We want things to be faster. Second, resources. By just using multi-threading, we can make a better use of our resources, doing one thing, do another thing in parallel concurrently. Simplicity. That's, I was a little bit afraid of like putting this here, because some people may argue that multi-threading adds complexity. And in part it's true, depending on your case, but also by having a divide and conquer approach, you know, splitting our big problem into smaller problems by just, you know, performing in different, tinier tasks, that could bring up simplicity, and we will see it later too. So, what I did here is get to the practical, oh, I forgot to start this. The practical part of this talk. And I put a problem, and that we need to solve using different approaches. So there's going to be some source code here. Everything's going to be in Kotlin. I don't see any reason to still write Java on Android. It's something that it's personal, but you know, with a modern language and concise and all these benefits that Kotlin brings up, there's no reason, unless, of course, you have an old or a legacy Java code base. Anyway, I want you to keep in mind this thing. So, what we are going to do is like it should be clear what's our goal here is. Okay? So, we're going to have a mobile device. This is, of course, for learning purpose. We're going to get some Wikipedia pages, right? Some Wikipedia pages. Then we're going to grab for each page, each Wikipedia page, we're going to grab the text on this page, and we're going to loop through each word and count it, okay? Simple process. Keep that in mind, because it's important to understand what we are trying to achieve here. So all the source code is actually available on my GitHub account, so feel free to contribute. There's room for improvement, of course. So, in my defense, that's important to say, I'm a strong believer of this statement here. So first make your code work, then make it right, then make it fast, if it isn't fast enough. Make it right here, maybe not. Because for learning purpose, I simplify a bunch of things, and there's like, I'm a big defender of you know, clean code, but this is dirty code. So, in part, yeah. But it's because for the purpose of learning, you know, what's going on. We can discuss that later, of course. So, let's get started with the practical side of this. So I'm going to start with threads and locks. Threads and locks, I'm going to start solving this problem by using the fundamental blocks in multi-threading. Threads and locks. Why? Because I'm not encouraging you to use this. Please don't. Don't go like and start creating threads in Java or Kotlin or whatever, because it's not the way to go, and you will add a lot of complexity and a lot of overhead. But it's important to understand what's going on, because sometimes we run into situations where we have some problems, some super weird problems, and then we don't know what's going on. And by understanding this gives us more room, more stuff, you know, more tactics or strategies in order to solve our problems. Hi, Jonathan. I already mentioned you, but like you were not here. You owe me a beer. So threads and logs. Let's start. There's a bunch of code here. I don't want you to understand each single line of code. I'll be explaining what's going on here, only the fundamental parts. So, remember, grabbing Wikipedia pages. This is running not online. I'm not doing a request. So, Wikipedia allows you to dump all the data offline. So I put here, if we go back, there's going to be 2 XML files of 30 megabytes each one. So of Wikipedia pages. Why XML? Because XML is very slow to parse. And I wanted to see how much progress we can see, how much better we can do. So keep that in mind. 2 XML files, again, Wikipedia pages in each XML file, grabbing each page, grabbing the text for each page, and counting it. Simple as that. Threads and logs. So here, what's going on? Let's see. So Kotlin has this measure time millis function, which is going to return how much time was spent there. But yeah, let's not pay attention to the details. So what I'm doing here is creating a new thread with a pages 1 and pages 2. These are the 2 XML files, okay? So what I'm doing is I'm grabbing each page here, I'm grabbing the text for each page, and I'm counting a word, each word. And I'm putting this count word into a map, into a hash map. Simple as that, yeah? So this took 21 seconds, almost 22 seconds. I found this amount of words in these 2 files. Yeah, and everything was run on an Android device. It doesn't matter, it could have been run in a computer. And yeah, here as you can see the log output. Keep this number in mind. So 21, almost 22 seconds. So I decided, okay, one thread doing one part of the job. Let's add another thread, because, you know, this is what you think, like, okay, so if one thread is doing a good job or an okay job, 21 seconds is still a lot. And I said, okay, let's grab 2 threads. So I'm splitting up my work here, and I said, okay, I'm going to create one thread, I'm going to parse all this in one thread, I'm going to create another thread. Don't pay attention to these numbers. These are going to be more important by the end of the talk, okay? But like, keep the big picture of that. And I'm going to process this, all this, and all this, and I'm going to measure. I'm going to start both threads at the same time, and yeah, I'm going to wait till its execution. And I'm counting the word here. First tip here. When we're passing from, you know, a mono-thread solution to a multi-thread solution, then it's not like, I mean, even if you're using a collection here, I changed to concurrent hash map in order to be thread safe when accessing to the map, right? Sometimes we think that by just changing this, because the contract is going to be still a hash map, you know, it's going to be a map contract, we still need to modify our code. It's not like changing, okay, so instead of using a hash map, I'm going to use a concurrent hash map and I'm completely safe. No. These things. This raises an error. Because this is not an atomic operation. And there might be some race conditions here when accessing the map. And so that's my first tip. First, never assume that by changing just, you know, your collection or whatever, one line of code, everything's going to, you know, run magically, you know, thread safe. So I changed that. I'm still using a concurrent hash map. I'm counting words. I'm using this merge operation. So this is atomic. This only happens in one cycle. So you don't have to worry about it. And the beauty of Kotlin code, like in conciseness. So I'm just counting my word, adding one, right? Let's see how much it took. Do you think that we got better? Remember, like almost 22 seconds. By just adding 2 threads, do you think that in theory, 1 thread, 21 seconds, 2 thread, 12, right? Yeah. No, not really. But we got better. We got a little bit better. From 22 seconds to, I don't know, 19, 3 seconds, but like adding 1 thread, that doesn't make a lot of sense, right? So I decided, okay, threads and logs, you know, the native threads and logs are working, of course. Let's go with another approach, RxJava. And I have to say also here, I agree with Jonathan, like some people are using RxJava because of only the threading thing. And please don't do that. I mean, really use RxJava if you really have, you know, a real use case for that. If you need to compose many sources of data from different, you know, resources or whatever, and you need to compose them and use all these operators and merge them and deal with that data, then use RxJava. Because otherwise you will be adding a lot of overhead. And I've seen code bases and people telling me, I'm using RxJava. Why? That's a good question. It's not because of the multi-threading. Using multi-threading in Java is super simple because you're adding only schedulers and that's it. You say here something like, okay, I want this operation, this observable, this monadic type, and I want it to run it on some kind of scheduler, let's say pool of threads or whatever, and I want to get the results, the mission on the UI thread. That's it. But you might end up paying a price here if you're not using RxJava for use case. But here, I wanted to check it out. I want to see how RxJava perform in comparison with threads and logs. Because in the end, all these scalers are using threads and logs. So, first example, again, same, 1 thread. I'm creating an observable here. For all of you who are not familiar with the concept of a monad, observable is a monad, which means the easy way to explain this is like a monad is like a bubble which encapsulates a computation. So you can do something there, right? And until you subscribe to it, nothing happens. So I'm just creating my observable, my computation, 2 things. Again, page 1, file 1, file 2, looping through all the pages to all the words and counting them here. Using a hash map, because I'm thread safe, only 1 thread accessing to the map. And I'm here executing my thing in a single scheduler. This means that 1 thread is going to be created. Let's see the results. 20 seconds, 21. 1 second faster than my first approach with 1 thread using threads and logs. That's curious. Let's say, why? If this under the hood is using threads and logs, because I checked the source code, right? And everything drills down to threads and logs. And I said, why? Maybe my code is terrible. So then I said, okay, let's try again. 2 threads with RxJava. Let's see the results. Again, same here, you know, creating 1 observable, which is going to execute in a new thread, another observable, which is going to be executed in another thread, and I'm going to, with this operator, I'm going to merge both results, yeah? I'm going to log the stuff, and I'm going to start its execution in parallel. So the merge operator, just for the sake of information, runs things in parallel. So it's going to grab both observables, start, you know, meeting and merging, you know, items as they come in. And again, since I'm in a concurrent environment, then I change my collection to concurrent hash map, and I'm using this atomic operation again. See the results. 17. We are getting a little bit better. A little bit better. I mean, if we, in terms of percentage, it's fine. I would say, like, by just not doing much. But we still, then I said, okay, I need to try something else. I'm going to compare the results. So I decided, okay, I'm going to use Kotlin coroutines. You know, since Kotlin coroutines, I'm not here to really explain, you know, what coroutines are or how they work. I mean, the only thing that you need to know is like they're lightweight threads, which means, you know, a Kotlin coroutine doesn't map straight to one thread. So a Kotlin coroutine doesn't mean one thread. Threads are very expensive to create, right? So we want to avoid creating threads, and threads, because threads are an operating system feature. So the operating system handles or manages all the threads. And sometimes we have threads available, and if we start creating tons of threads, then we're going to see a very high impact on our performance. So coroutines, I mean, there's a lot of magic. We can execute Kotlin coroutines like, I don't know, many coroutines within one thread, which is, you know, that's the power of Kotlin coroutines. And I'm going to show you how we can do that. The other good thing about coroutine is like, you don't have to deal about like, you know, synchronizing between threads and so forth. It's super simple because you only, you know, write code in a very synchronous way. You just like, you know, you define your suspend functions, and I'm going to get back to it later. And then you can write synchronous code, which is super easy to understand. This is just for the sake of like a simple example. So, yeah, so something else to add here. Coroutines are basically a language feature. It's not an operating system feature. So there is a lot of compilation or compiler magic going on. So we write all this code and compiler will transform a lot of things here. They actually work. This is for information, right? You can dive deeper then. How they work is like, it's continuation programming, which is like, you know, you can start a coroutine and then it's going to start it in a new thread, and then it's going to pass like a lambda or something. It has like a state machine, which is very interesting how it works. I cannot provide all the information because we can spend an hour, you know, trying to figure it out together. But anyway, keep that in mind. Coroutines are lightweight threads. Let's see our example here. So again, one thread, one coroutine, let's say, no one thread. Still one thread, but like, yeah, let's see how it goes. So this is the way how you launch a coroutine. So I'm just saying, okay, this is a Kotlin feature, so I'm launching some kind of computation here, and I decided you can pass a context to a coroutine, which means I want to use the thread or the other thread within a coroutine. So basically, in order to have one thread, I decided, okay, I'm going to pass this, you know, new single thread context, which is something that Kotlin provides. And I said, okay, I'm going to start counting. I'm going to execute my counter, which here is where the magic is happening. So I'm saying counter here, everything that you put inside a coroutine must be a suspend function, which means, you know, the reason why it's defined with suspend is because of all this compiler magic that's going on. But for you, it's totally transparent. You just define a coroutine as a suspend function, and that's it. That's all you need. So, okay, I said, okay, this is being executed within one thread with a Kotlin coroutine. Same thing. Counting. Let's see the results. 21 seconds again. Okay, fine. Nothing to say. So I decided, okay, 2 threads with Kotlin coroutines. Let's see how they perform, if they are reusing or not. Change my my collection here. I'm using a pool of threads with 2 threads. I'm executing this coroutine here. As soon as you declare this way, it's going to start right away, right? 2 coroutines starting at the same time, and then what I'm telling my thread here is like, just wait till all these two jobs are done, and then I can log the time when they're done. So I have my two coroutines here and the same piece of code. Let's see how this was. 19 seconds again. I was writing this code, it's like, what the hell I'm doing here? I'm not getting any better. But I learned a lot, I had to say, because I run into a lot of issues as well. So this is our first round of results. So the winner here was our Java 2. And that brings up a lot of questions, like why? I didn't figure it out, to be honest. But I think as far as I know, there's some caching and other things that are way more complex under the hood in RxJava. But still, that's not the reason or a strong argument in order to use it, right? For me, it was like, okay, I mean, the difference is not pretty big, I would say. So I said this. So in the end, I started thinking, what I'm doing here. I'm adding a new thread. So why is not going any better here? Why? What are the whys? So I came up with some hypotheses. So let's try to understand what's going on. Of course, we can do better here. And I said, okay, yeah, of course I can do better. How? I can start using some multi-threading patterns, like consumer-producer pattern. I don't know. So all these things that just came to my mind. Producer-consumer pattern is like one thread producing some jobs, sharing it in a blocking queue, and then other thread like grabbing that job. I don't know, things that came to my mind. Maybe divide and conquer, like split the problem into even smaller parts. I don't know. Reusing threads? Maybe I can find a way to reuse a thread, I don't know, do some caching. Or maybe I'm not using the right synchronized collection, the concurrent hash map. I know that there's other options that we can use to store the data. And that's when I said, I mean, never make assumptions. Just analyze the problem, see what's going on. That's what I did. Verify your assumptions. Yeah, because I think, like when you're writing some code, say, I'm going to improve that code. Yeah, and you start writing new code. It's like, did you measure? No. But then how would you know you improved it? Because it's coming from common sense. But like, those are assumptions, and we are speculating. We think that we are improving stuff. So my advice here is measure, 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 measure. Because you really need like some kind of a strong argument, right? In order to get better, you need to measure, you need to have some numbers, and then afterwards, come up with the difference as I've been doing here. So my first hypothesis was like, I'm using the right concurrent collection. So the hash map, the concurrent hash map in a multi-thread, because I don't care about the monothread. It's totally fine. I wanted to get better. So I know there's other concurrent collections, maybe hash table, maybe this wrapper, like a concurrent map, and passing a normal hash map. So I decided, okay, I'm going to verify my assumptions. I grabbed my concurrent hash map here and said, okay, I'm going to try every collection that I consider useful in this case. So I said, okay, I'm going to try hash table. I'm going to add like 500,000 entries. Add it and get it. And see how that goes. In my computer, actually. And of course, like, this is endless. We could try it. It depends so much on our hardware. It depends so much on many things. But it's better than nothing, right? And I said, okay, synchronize a map and a concurrent hash map. So clearly, the winner, it was a concurrent hash map, and by far performs better. So I said, okay, I'm using the right concurrent collection. So let's get to the next hypothesis. Other things I started thinking about is like, why is this so slow? Maybe the XML parsing, because XML is not It's not easy to parse. It's very, I don't know, it's very difficult and it's very slow, right? And I don't know how many people are using XML. Honestly, nowadays, that was a challenge. So I thought, okay, since I'm using two files, maybe the parsing thing. You know, when you're doing a lot of input-output and reading from disk, maybe your threads are idle, waiting for the input-output, because reading from the disk, it's always slower. So maybe my threads are waiting for the input-output. So that was another hypothesis. And say, okay, let's check it out. Say, okay, I'm going to grab the part when I'm parsing the XML file. I grabbed like randomly the RxJava since it was the best one. And I said, okay, let's see how much time I'm spending on each specific task here. When I'm creating the page, when I'm just grabbing, you know, that and mapping that to an object, it's very fast. Page 1, when I create it, when I'm doing the new. So page creation only takes 28, just reading the path, you know, to the file. Then I said, okay, time parsing XML file. For the first one, it was like 4 seconds. So this means like looping through the file and so forth. And once I have all these nodes in memory, then it's very fast as well, right? And with the second one, it took even longer, a little bit, but it's not a big difference. So clearly, something is wrong here, because from my computation, half of the time is being spent when reading from input-output, which is this XML file. So then I said, okay, what are my bottlenecks? And first conclusions. Again, threads being idle. Maybe I'm locking, since there's tons of elements, you know, locking the map in order to insert those elements is taking some time. And then after I gave this talk, you know, 1 month ago, someone just was exploring my code, and that's a good thing about contribution. And this person said, okay, so I inspected garbage collection. And since you're creating tons of objects around, there's a lot of garbage collection activity. I just put it here, but I haven't done that yet. I trusted this person. He looks a really nice guy, and you know, give me a beer and so and say, okay, why not? Anyway, but we can do better anyway. So then I decided, okay, I'm going to write some more code. I think we can. There's still room for improvement. How can I get better? Again, this is where my approach is, things that come into my mind and so forth. So I said, okay, I'm going to use KOTLIN coroutines. Because it's the easiest way for me in terms of code readability here. And I decided, okay, I'm going to split up my problem into smaller problems. So let me explain a little bit the code here. So I'm still reading 2 files, but I decided, okay, maybe I can create some range, you know, and read from one thread to the half of the file, and then with another thread to the other half of the file, and then with another thread, the second file, the first half, and so forth. And I did a counter here. Yep. And I count my words and so forth. Do you think we got better? Yes, no? Who thinks yes? Okay. Yeah, we're all afraid of saying this. Hold on, then it's going to be super worse. Let's see the results. Okay. We improved our solution. I mean, almost 14 seconds, it's okay. We started from 22. If you think about a percentage, it's okay. Hey, it's getting crazy. You like it? Good. So then I said, here's the results. So just to recap, you know, our solution is like, okay, 14 seconds. It's not pretty bad from our worst case. It's in the end, I don't know, 7 seconds, 30% better. which is a lot if you think about it. I mean, you might not, and please don't parse XML files on your phones, but keep this in mind. This is about problem solving and understanding what's going on and how we can write, concurrent code. So I said, we can do better. But that's your homework. Because I was so tired then, at some point, it's like, no, man, I mean, the audience is going to kill me. I think, like, contribution should be nice, but I got a bunch of ideas out of that, right? I said, okay, maybe I can start, or I can continue trying to, use more threads and logs, only for the purpose of learning again. Maybe more coroutines, and why not using functional programming and bringing other approach from other technologies. I started actually by using Clojure and trying to solve the same problem with Clojure, with a pure functional programming language. But then I started, dealing with that. I saw, the Clojure syntax, and, a friend called me and said, let's go for a beer. I said, yeah, of course. I don't want to deal with this right now. So that's the magic about contribution. There's a bunch of discussions. This is a repo. Just feel free to just check the code, send PRs, or just open an issue. We can start a discussion. I like that. I like the GitHub way, because we can start, like, people contributing and so forth. But then, other things that were useful while writing all this code were the things that we face when writing concurrent code. Debugging is not easy, something that we always need to know, and that adds kind of a complexity, right? Because then our software is hard to debug, and yeah, mutability is very important again. So please don't share state between your objects, especially in multi-threaded environments. Testing, of course, when writing tests for concurrent code is very challenging. I mean, we can discuss all this. I didn't have enough time, and in 45 minutes, it's difficult to put everything here, right? But I want to raise discussions and questions around it. And that's my first conclusion. That's why it's important to know the fundamental buildings. If we understand this, then we know what's going on. We know what's going on, with job scheduler, with work scheduler, with all these Android things that in the end up here. And sometimes you need to debug and go deeper and check the code, and you have a better understanding. So my first verdict was always use the right tool for the job. So again, this was related to RxJava. Many people say, okay, now I'm going to use RxJava. Okay, why? Please don't do it because of only multi-threading. You really need to have, like, a good reason to introduce it in your code, because otherwise you end up marrying to RxJava, and then all over the place RxJava observables, singles, and flowables, and whatever. And that may add complexity when you really don't need it. Measure, always measure. Don't make assumptions, and you say, okay, this, I heard that this for loop is faster than this other one. It's like, okay, but please have a proof of that, because I said something. It's like, doesn't mean that it's set in stone, right? And no silver bullets. Again, this is again like a defense mechanism when you always say no silver bullets. So don't worry. Whatever I did here, there might be other better solutions. Of course there are. Again, just to come back to this, first make your code work, right? Then make it right. Unless you're trying stuff, just write dirty code, but like, your other developers in your team will appreciate that you're putting all your effort in writing clean code with good practices. And then it's like when you should tackle performance. I always say that performance shouldn't be your first priority unless that it's key for your business. For example, if you're writing a real-time software, then you definitely need to tackle performance. And something else to explore just super quickly: memory consumption, garbage collection, Android threading components. I think from the previous talk you might have like a good idea to try things out. Other external libraries. I was curious about the Evernote library, but it seems it's going to be no longer maintained. The iOS threading model, I know they have like the central dispatcher, and that's a way to go that Apple encourage developers to go when dealing with multi-threading. And correct me if I'm wrong, then the iOS developers here. Server-side multi-threading, again, bringing ideas from other technologies. That's a +1 in order to understand better and not only focus on specific frameworks, let's say Android or iOS, in order to be better when solving problems. And contribution is always important. I try to do my best with that. I encourage everyone, just like open a ticket. It's easier, to ask questions. Ping on Twitter, add on Facebook. I think I sold my soul to all these social networks, so they have all my information already. So you can find me publicly by Googling. And out of curiosity, and I'm done with this, other things that may be worth understanding is the actor model, which is about message passing. It's a very popular technique at a backend level, and they have actors, and they are sending messages to each other. So maybe it's good to explore, and maybe why not bringing that to Android? Who knows? FP languages, as I said, Clojure, Scala, Haskell, things to try out. And again, use multi-threading mainly because of responsiveness, better use of resources, and simplicity. And I think that's all I have to offer today. I'll be around for a few minutes, and this is where you can find me: Twitter, my blog, and GitHub. Just feel free to ask any question. There's no dumb questions. You can ask anything, and I will try to do my best. So thank you.
Thank you so much. And we have a couple minutes about question. If you have a question, just push your arms up. Okay, I see.
Thank you for the presentation.
You're welcome.
And my question is, how did you measure the time? And was it the average time that you showed us? If so, how many measurements did you make?
I mean, if you go, it was basically execution time from the very beginning when you start, parsing the first page, and till the end when the operation was done. Just to give you here, yeah. So it was total execution time.
Yes, I understand that. I mean, did you test it on a fresh device? So no thermal throttling?
I get it. Yeah, that's a good question, actually. And in order to answer it, yes, different devices react differently. And actually, I have to say that I got better numbers when bumping different versions. When using different versions of RxJava or Kotlin coroutines, it seems that there might be changes, and internally, of course. And the numbers were a little bit different, but more or less similar. Except, like, for example, I think I found a couple of issues in very old Android device because of the way it works. But yeah, that's something we need to keep in mind, actually, and try to use different environments. Here, for the purpose of learning, use a couple with different versions, and that's it. Good.
Any question more?
Any questions, or we can go for a coffee? As I said, like, I have 20 minutes or half an hour, and we can talk, and please come by and say hi at least. Okay? Good?
Okay,
Thank you very much.